In this video, I'm going to delve deeper into the handshaking between the TNC 155 and the Izumi PLC, which you can see here. The reason for using this as the demonstration is that the outputs of these inputs in this area here, inputs and outputs of the Izumi, have these LEDs that tell you when any of the inputs or outputs are on. This whole input-output system is floating, optically isolated, and it runs on the same 24-volt supply as the backplane of the Heidenhain. So what we can see here is it's monitoring the gear change cams in this here. Here it's actually driving some relay coils that are on the same 24-volt system that actually pull in the main contactors. They're converting from 24 volts to 20 volts on the contactors. Up here we have the communication to these 8 bits of communications hardwired here to the backplane of the TNC 155, and in fact these J numbers are actually the numbers on the backplane of the Heidenhain, and also these here on the backplane. You can see here this is a strobe for M machine codes, and this is the strobe for speeds, again coming from the Heidenhain. There's also here an auxiliary function that's got the same, sends back, the Izumi sends back to the Heidenhain. It again has the jumper numbers and output numbers of the Heidenhain here, J5-7. Here, these two guys here, when the Izumi is doing the gear change, these will alternate back and forth to nid-nod the motor, the main spindle motor, backwards and forwards. We don't need to take much notice of the tool unclamp. It's basically telling the Izumi not to do anything if the motor's if the tool's unclamped. You don't want the main motor to run and take your hand off, or you don't want to start the thing with the tool not clamped in place and have it fly around the workshop. It's worth noting that the indicator light that is off is actually telling you which cam that the switch is on, or which gear that selector is in. So you can see here, these lights here are telling you that it's actually requesting, or the gearbox is sitting in the speed 50 RPM. So what we can actually see is that the gearbox selector on selector 1 is on cam 1. The selector on number 2 selector is sitting on cam 3, and for the third selector it's sitting on cam 3, which tells me it's sitting there waiting to start at 50 RPM. So what we're doing is actually using these indicator lights as a mimic panel. It's a nice way of visualizing the very momentary strobing and outputs that are zooming backwards and forwards during the handshaking. So next I'm going to take a video of it shifting from 50 revs per minute to 2,500 revs a minute, the two extremes ratios on the gearbox, and then doing a star delta start. Before we go any further, I thought I should actually explain what's going on with this, what these things are on the Izumi. Over here we have the CPU unit, which we don't need to really worry about. This and this are 24 volt input modules, and this is the output module to do the pushing and shoving. Okay, we've done all this, I think, correctly. And these two here are actually sensing for this to tell the Izumi. They're looking at the hardwired output of MO3 and MO4 on the from the Heidenhain. These two 24-volt coils actually pull in the main contactors for the forward and aft on the spindle motor, but I just wanted to sense the status of these coils just for a bit of the logic. This and this, as previously described, the forward and aft jogging. So the relay coil here outputs 220 volts to the forward and reverse jogging during the gear change. These here actually power directly at 24 volts the three gear change electric motors. They're actually seconded Bosch windscreen wiper motors on this particular machine, and this here swaps the polarity on these so that the selector can be hunted either forward or backwards. And this here is a logic output that does a lot of swapping around of contacts and things to allow a whole lot of things to happen in the schematic drawings to change it into a mode for gear change from. So basically these guys here are jogged forward and aft at a reduced voltage. This is the return signal that says all gear change or star delta starts are over. And here is a thing where this outputs to a relay that is what actually swaps between star and delta after the timers inside this and the ladder logic have given an appropriate star delay for the motor to start. I've just pushed the program run button to initiate a gear change to 2,500 revs per minute and then a motor start. So now we'll stop action every time there is a change in the lights and do some logic analysis. The Heidenhain has just set J25 and J28 to 1. So the bits on the backplane read 001, 001, which is the request for 2,500 revs per minute. You can see that J33, the S strobe, has strobed the data into the Izumi, and we've just caught, so I don't have a frame that separates it, but you can see below the Izumi lights responsible for the gear change are about half illuminated, very quick. So the Izumi is now leapt into life to do the gear change. It's switched on 11D2, which rearranges quite a bit of the wiring. And so it's already switched on 11D3, which switches over the main motor from the 415 volts to a 150 volt AC three-phase transformer winding. And instead of using the 1K1, 1K2 high voltage contactors, it's now using the low voltage 11K1 and 11K2 contactors, which have just begun nid-nod action on the main spindle motor direct online in the forward direction using the 11D3 relay. It's also started running the first of the selector motors, 11M1, 11D5, but it knows from 11M1 CAN5 that it has to run it in reverse direction, so it's set 11D8 to reverse the voltage on that first selector motor. Here it's decided that the first nid of the nid nods on the spindle motor is finished and it's switched it off. Here the S strobe J33 has timed out and switched off. Here the selector motor has been running long enough for the cam to leave off 11M1 cam 1. Here 11D4 has come on to reverse the nid knob of the spindle motor. 11D4 of the reverse nid nod has just switched off. 11D3 of the forward nid nod switches on. 11D3 forward jog switches off. 11D4 reverse jog switches on again, but we can see selector 1 cam 3 has gone off. It's actually just passing over that. And cam 5 is just about to come on. Here we see the reverse jog of the spindle motor has finished, and cam 3 on spindle 1 has been passed over, and we're now fully on the direction cam 5. 11D3, the forward jog of the spindle motor starts again. And what happens in this jump? The spindle 1 has arrived at cam 2, which is its destination. So the PLC immediately switches over the drive motor to spindle 2. From here I'm going to skip ahead to the end of the gear change, because it's just going to repeat the same logic for selector 2 and selector 3. In fact, it actually wants to have them both on cam 2 to get to 2,500 breaths per minute. Here we are just a fraction away from the finish of the gear selections. Selector 3 on 11D7 is moments away from finishing. And here cam 2 on selector 3 has just been found, and almost simultaneously the Izumi sets the auxiliary function finished strobe on J57 to tell the Heidenhain that gear changing is finished. 11D7 on the cam motor is in the process of switching off. And 11D8, the reversing switch for the cam motors, is turning off. And now we see the entire gear change process has finished. The 3 selector cams are sitting on cam 2, which tells us it's sitting in gear for 2,500 rests per minute. All the cam motors are switched off, and the reverser is switched off. And most importantly, 11D2 has switched off, so all of the gear change orientation of the schematics has switched back to the normal mode. Also note that J2 bits 1 to 8 have been reset to 0. Here the J57 auxiliary function strobe to the Heidenhain has switched off. So now the Heidenhain can proceed to ask for the correct star delta start for the main spindle motor. Now the Heidenhain sets the first 2 bits of J2 jumpers, which represents an M code for MO3. It's also pulled in the 24 volt coil on MD3, which represents the hardwired output from the Heidenhain for MO3. That causes the spindle motor to start in star mode. The Heidenhain now switches on J3-4, the M strobe. The Izumi now knows to read the 2 J2 bits as 2500 RPM and looks through its program and selects the correct time delay for the star delta starter. And here, after the required 3-second or so delay, the Izumi pulls in a 24-volt relay coil, which turns on 11K5 and switches the spindle motor to delta mode. So now the motor startup is complete, and the Izumi again sets J57 strobe back to the Heidenhain to tell that the whole sequence is complete, and the Heidenhain is free to now continue machining to the Heidenhain's next program block. And finally, the Heidenhain acknowledges that the process is over and sets the bits on the J2 1 to 8 back to 0. And the whole sequence is complete.